mentioned fusion there and you mentioned Commonwealth. I thought it was fascinating when I thought about kind of the future of energy and when I was doing a lot of work prepping for this, because you said before, forcing non-economic solutions is the wrong approach to climate, and solutions will need to be at what I call the Chindia price. My bet is on fusion and geothermal. I just wanted to break this down because I didn't understand some of it, if I'm honest, which is, why is forcing non-economic solutions the wrong approach first?
Well, energy generally is such a large-scale problem that there's no way, we will spend the money to scale it. It's great for the first 1, 2, 3% of the market, whether it's the electricity market with solar and wind, or the hydrogen market, or pick your favorite. I believe subsidies should be declining with scale. So they can be high when it's 1% of the market because the tax on the overall energy cost would be low. But they have to start scaling down, and no subsidy is being designed that way, where as it gets to 2% or 4% or 8% or 15% of a segment, whether it's hydrogen to replace natural gas and coal, or solar or fusion to replace electricity from coal, it has to scale down. If it's not, it's going to become too expensive. Do you get clean energy and no healthcare spending? What are you going to trade off? Those are the kinds of practical things at scale that matter. Having said that, look, early subsidies help get technologies developed when they're subscale, but by the time they're 5% of a market, they really shouldn't need subsidies at all. Also, practically, if you're a politician in India, you're not going to tell people they can't have clean water, but their kids will be better off because there will be a less warm climate. It's a very hard political trade-off to make. Coal consumption's been increasing in some of the developing parts of the world. You can't defy the laws of economic gravity at scale. You can do it in small startup sort of situations, but not at scale. And for it to be contributing positively to economic development in countries like India or China, it has to be competitive globally with other sources, or it won't be adapted. And this leads to a very important point in climate. We don't need incremental solutions. We need large breakthrough technologies will make these new technologies competitive at scale. So we can take small risks and have incremental decline in costs, but that doesn't solve the problem because it won't be broadly adapted. Or we can take larger risks and, if successful, really have solution. Fusion's that kind of thing. Deep geothermal, 400 or 500 degrees centigrade geothermal, would be that. Finding a new geothermal site incrementally doesn't really help. It's not scalable. It needs to be scalable by 100x more than exists today, at least. And so my interest in technologies that scale and are economic and don't defy the law of economic gravity when scaled. Aviation fuel is a very simple example. And while we are talking about it, these take a long time, so sometimes the venture community ignores them, but they're profitable. If I look across our portfolio, some of the investments we made more than 10 years ago are, there's a whole number of them. QuantumScape, Verdagy, LanzaTech, Impossible Foods, that are 5 to 10x multiples, though they took a longer time to get there. So Climate 1.0 was successful if one was patient and picked the right technologies. Things like fusion, new plant proteins. I'm very excited about new fertilizer production techniques, new steel production techniques. We are taking radically different approaches in cement, steel. Those are really, really exciting breakthroughs, and there's no question they will be cheaper than its fossil alternative. Already I can say the cement we are producing will be 70% less carbon, and our first plants will be operational this year, and cheaper than traditional Portland cement. And that's when things start to scale.
Can I ask you on fusion, what is at the core of the bullishness, and how does fusion bankrupt entire industries and destroy massive companies like you've said before?
There was one breakthrough that enabled fusion to happen, which was high temperature superconductors. It wasn't possible to build a fusion reactor with a 20 Tesla magnet, which is what Commonwealth Fusion is doing. With that magnet, the size of the reactor scales to 1 over Tesla to the power of 4. So if you quadruple the power of the magnet, which one can do with high temperature superconductors, the reactor itself becomes 1 to 50th the size. So 250 times smaller. Because of that, you can now both be economic, but also experiment much more rapidly, build them much more rapidly. Commonwealth Fusion was able to build a 20 Tesla magnet for fusion and demonstrate it in 3.5 years. It has taken the large ITAR project with smaller magnets 25, 30 years to get to the same place, so 10x faster. I believe demonstrating positive energy by 25, maybe 26, will be also 10x faster. Not only has that happened, there's a dozen other credible projects in fusion that have been started, mostly because Commonwealth instigated this change towards fusion, and I have this theory you need instigators. And it's got sparked up a field that was slow and not attracting the best talent to attracting the best talent now. And there's probably a dozen startups, and that's what makes me optimistic. At least 1 or 2 or 3 will be successful in this.
How does fusion, how does geothermal, how does new energy resources and innovations within kind of their extraction, how does that rearrange international relations, do you think?
Well, if we can reduce our dependence on oil, we can dramatically reduce international tensions and what are called strategic interests. There's so much fighting over strategic resources like energy. The minerals and metals is the other area. We can eliminate that tension. Imagine the following. If you take every coal plant in the country, and its boiler, the coal boiler or a natural gas boiler, is replaced every 5 to 10 years. They deteriorate pretty quickly. If you could replace it with a fusion boiler, you wouldn't have to build 5,000 new power plants in the US. You just have to build 5,000 new boilers, which is less than the number of Liberty ships we built in 5 years during the Second World War. So that's how you achieve these at scale and completely change industries and our source of power, by being clever about it.